Welcome to Unit 6, where we will be talking about chemical bonds and molecules and how those bonds are created and how they are broken and how they form to make all the different infinite number of molecules that there are in the universe. So, first, we're going to start off with a few little definitions. First, what is a chemical bond? Basically, a bond is a force that holds atoms together. And it makes them function as one unit. So it holds two or more. Actually, I guess the bond is just between two atoms, but there can be more than one bond. But those bonds hold the atoms together and cause them to move together as one and to work together as one thing. So when we talk about a force, right, that basically means energy. So when we talk about that bonding energy, that force that holds atoms together, basically bonding energy is the amount of energy that is required to break a bond. So how much energy is in that bond? Think of it as potential energy, right, when it's in the bond, and how much energy then is released when that bond is broken. And I know we've talked in the past about how everything in the universe likes to be at its most stable, lowest energy level. Right? It takes work to do things, and things in nature, even down to the basic unit of atoms, want to be at that lowest possible energy level. So when more than one atom bonds together, it's because the system, whatever that system happens to be, you probably learned in biology about different systems, but the system can achieve the lowest possible energy. So those atoms bonded together is lower energy than if they were separate. You can think of the system that is the atmosphere, right? Oxygen will always bond with itself. You never find oxygen out in nature alone. It is always bonded two oxygen atoms together. That's because the energy is lower when those two atoms can be bonded together. So, like it says here, a bond will form if the energy of the bonded atoms is lower than the energy of the separated atoms. So, if energy is lower, bonds will form. There are three types of bonds, actually. We're going to talk about two really here. I'll mention the third one, but it's not even in your notes. So, the first type of bond is a covalent bond. And a covalent bond is formed when electrons are shared. We've kind of talked about this in the past, but those electrons are shared by the nuclei of two atoms. The covalent bonds are always two or more nonmetals. So those things over in the upper right-hand corner of the periodic table, carbon, nitrogen, oxygen, fluorine, chlorine, sulfur, all right, that is a covalent bond, which I guess if I'd been paying attention is written right here and I didn't have to write it at the top. So nonmetal atoms react to form a covalent bond, so that the atoms can achieve a noble gas electron configuration, which means a full octet of electrons, right? Full octet of electrons. They want 8. In this example, hydrogen really just wants 2 because it only has that first energy level. By itself, it has 1, but bonded together, they share those 2, which gives a full energy level. Like I was talking about, I'm going to flip this over. Like I was talking about with oxygen, right? Oxygen, if you were to look at the periodic table, it by itself has 8 electrons, 2 in this first shell, and 1, 2, 3, 4, 5, 6 in the second shell. So if we have two oxygens, there's the nucleus, first energy level, second energy level, 1, 2, 3, 4, 5, 6, 2 in that first energy level. So remember, 8 makes it a full octet, right? So let me draw this oxygen a little bit different to make it easier. Let's put that one over there. So if these two oxygens share these electrons and share these electrons, then there are 8, 1, 2, 3, 4, 5, 6, 7, 8 in this outer shell, and 1, 2, 3, 4, 5, 6, 7, 8 in this outer shell, and the oxygen is very stable like that, right? To draw that a different way, that actually creates a double bond between those two because they're sharing 4 electrons total, and that makes it more stable. But those are covalent bonds. I think we've talked about those before a little bit. In an ionic bond, though, ionic bond's a little bit different. It's basically a force of attraction between an atom that loses electrons easily. That would be something from the left-hand side of the periodic table. And an atom that has a high electron affinity, which means it wants electrons. It gains them easily, right? Those are things that are nonmetals and more on the right-hand side of the periodic table. So like it says here, an ion, we had our metal reacting with a nonmetal to form that ionic bond. And what happens here is the nonmetal and the metal ions. So that's the important word in this whole thing about ionic bonds. Those ions form so that each of them achieve that full noble gas electron configuration. So what happens, we'll look in this picture here. Lithium has 3 electrons. This is okay, I see what's happened. It's lost one already. So lithium at a neutral state has 3 electrons. This one only has 2, which gives it that positive charge, right? Fluorine normally has 9 electrons, but as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it has gotten an extra one from lithium, which gives it that negative charge. So we have a positive ion and a negative ion. They are attracted to each other, which forms the ionic bond. So as opposed to sharing up here, we have lithium gave away an electron to fluorine, which causes a positive and a negative charge, which causes them to be attracted to each other. We are not going to worry about this electron configuration. Mostly, I just wanted to define those two bonds for you.